Okay, well, we will go ahead and get started, and anybody who joins late will join late. I want to welcome you all to day 2 of our Science and Ag Week. My name is Dr. Nick Morris. I am the program specialist with the State 4-H program for Arizona 4-H, based in Tucson, Arizona, and coming to you live right now actually from Ohio. So I am really excited for day 2. We had a great presentation yesterday from 2 of our graduate student fellows talking about sustainability, and we're continuing on today with the topic of plant sciences. And as we did yesterday, just kind of introducing and reminding everybody that our goals today are to learn a little bit about how science skills and strategies are used in agricultural contexts, and think about problem solving using those skills just as a way to add a little bit of knowledge base to the work that we do in 4-H and as young people, and thinking about how we consider our roles in agriculture and where science fits. So we'll be hearing today about plant science context and bioproducts. And I did cover yesterday, so I'll do again for anybody who's new. But with the webinar feature that we are using, you are not being viewed by any of our panelists. So we are not sure what you look like or what your background is, and you're completely muted. So for those of you who are simply attending, if your dog starts barking in the background, you don't have to yell at it. We won't be able to hear it. So we will use a couple different tools during the session today. There's a chat box, and I know many of you, I recognize some names from yesterday and from some of our other online engagements. So our panelists may suggest that you answer a question in the chat box. And if you have a general question, you can feel free to tap that question and answer icon, type in a question, and then the 3 of us will be able to see it and make sure that your question gets answered. So I'm looking forward to the engagement today, and without further ado, I'm going to introduce our speakers today. So our first panelist is Arisbeth Ibarra Nieblas. She is an engineer from Sonora, Mexico, holding a bachelor's degree in chemical engineering, a master's degree in environmental engineering, and she is currently a PhD student in the environmental engineering program at the University of Arizona. And we also have Ali Yailali. He is a doctoral student and former teacher of English as a second language. He studies language literacy and education at the College of Education, the University of Arizona. And his areas of interest are academic writing, science writing in high school classrooms. And currently he is, along with Arisbeth, working as a partner with Arizona 4-H on the Sustainable Bioeconomy for Arid Regions project, and is teaching linguistics courses for future teachers. So just like yesterday, we've got some great experts to share what they know with us today and engage with you. So feel free to enjoy the presentation and chat and engage with us as you see fit. Look forward to the presentation, and I hope you do as well. And my fellow panelists, I'll turn it over to you.
Okay. Ali, are we going to do the poll? No.
We can get started with the poll, Arisbeth, if you would like. After maybe we introduce what we are doing first.
Okay. So today we're going to be talking about bioproducts, and we're going to learn 2 things today. The first thing is to identify the different types of bioproducts, which we have 3. And the second one is that at the end of today, we're going to be able to solve a problem using a plant and its bioproduct. So I have a question for you guys. Which products can we get from corn that are not food or feed? So think about anything that we can get from corn, but that humans cannot eat and animals cannot eat. If you're thinking about like corn oil, that's for cooking. So that's not, that will be considered food. So just think of all the products we can get from corn that humans cannot eat, nor animals. And you can put that answer on the chat. So we're gonna give you guys a few minutes for you guys to think of any products that we can get from corn that are not for food or for feed. Okay, so I'm seeing some answers right now. I'm seeing one that's very popular. Okay, so I see some of you put ethanol, and ethanol is one of the things we can get from corn that will not be considered food or feed. Some of the other things we can get are textiles, like cloth. Other things we can get are like polymers. Those are like plastic-like materials. And we can also get vitamins or supplements. So products that we get from plants that are not considered food or feed are called bioproducts. And the steps to making it bioproducts go a little bit like this. So farmers grow a particular plant, and there's a problem or need in the world. And scientists do research to learn how to solve this problem using the plant that farmers are growing. And then later, engineers come and they use the plants and the knowledge learned from the scientists to solve the problem in a larger scale. So in order to make bioproducts successful, we need farmers, scientists, and engineers.
In this slide, I will talk about what scientists and engineers, what skills scientists and engineers possess to solve our everyday problems and meet our needs daily. So to be able to come up with those bioproducts and come up with solutions, of course, scientists have very advanced skills. And for example, they process plants for chemical extraction. And they can analyze soil, its pH degree or moisture level. And they also need to understand how plants grow in different conditions, right? Their habitats, because we are talking about plants particularly today. And also technology is very much involved in this process. So they are very knowledgeable about irrigation technologies that are used in the US or Southwest or particular regions. And available water resources underground or on the surface are also part of the skills that they have to know about. In all of these processes, scientists, engineers, they design and they use different technologies. And some of those are sensors or drones. Even if you think about agriculture field, these are very high-tech devices, tools are being used. So if you are interested in agriculture, just keep it in mind that, or plant science, keep in mind that there's a lot of technology involved in that process. They also have to keep very accurate and precise records because they are making high-stakes decisions based on delicate data that they collect from their measurements. So to hopefully, if you decide to be a scientist or an engineer in the future, just keep it in mind that there are very advanced skills like these that scientists have developed over time.
Okay, so I have another question for you guys, but this is just for you to think about. Can we grow any type of plant anywhere? So here we have the two photos. On the left, we have papayas, and on the right, we have cotton. So we can see like the background, the environment where these plants are very different. So can we grow any type of plant anywhere? Oh, I see some people are answering. They said no. Yes, so the answer is no, we cannot grow any type of plant anywhere because different plants need different growing conditions. And now we're going to talk about the growing conditions here in the Sonoran Desert. So the first one, water. Do we have a lot of water compared to other places? Do we have a little bit of water compared to other places? So we don't have a lot of water compared to most places. And then sunlight, do we get a lot of sunlight? Do we get a little bit of sunlight? So here we get a lot of sunlight here in the Sonoran Desert. And then for soil, you guys might not know pH, but pH, we can measure pH from 1 to 14. And the soil pH in the Sonoran Desert, it's around 7 to 8 pH. And for climate, do we have a tropical climate, humid climate, cold climate? Here in the Sonoran Desert, we have like a dry climate and it's very hot. So I have 3 types of plants here. We have blueberries, papaya, and guayuli. So which of these plants can grow the best here in the Sonoran Desert? So we're gonna start going over the soil pH of each plant. So blueberries like the pH of the soil to be between 3 and 4, which that's too low for the Sonoran Desert pH, which is between 7 and 8. So next, the papaya likes the pH soil between 5 and 6. That's still too low. If you go to guayuli, it likes a pH between 6 to 8.5, which gets closer to the pH we have here at the Sonoran Desert. All 3 plants like having a full sun, which is not a problem for the Sonoran Desert. But then we go to temperature. For blueberry, it likes to have very low temperatures. So for like summer days like today, the blueberry will not like it at all. And then for papaya, we're getting closer between 70 to 90. And guayuli, its ideal temperature for growing is between 90 to 100 degrees Fahrenheit, which is in the range of most. I see some people putting the answer on there. And then we're gonna go on the last one for habitat. Blueberries like the habitat to be temperate, which is forest-like. So do we have forest-like environment here? And papaya likes to have a tropical, which is jungle-like. And then guayuli likes the desert habitat. So the answer is, which I think everybody got, it's guayuli. So guayuli will be the plant that will grow the best out of these 3 plants in the Sonoran Desert. So then I will give you guys a minute to read these 2 definitions. So read the definition in the blue box and then read the definition in the green box. Okay, so then plants would be considered non-renewable sources or renewable sources. So plants will be considered renewable sources because renewable sources can grow again and again or never run out. So plants, we can plant them and they will grow again. So they are considered renewable sources. Another renewable source will be the sun because it will take a very, very long time for the sun to run out or not be the sun anymore. And renewable sources, an example would be coal, because coal, it took millions and millions of years for coal to be produced. So non-renewable sources will run out or will not be replenished for a very, very long time. Another example of this is gasoline. So for bioproducts, again, bioproducts are made from biological renewable sources. When we say biological, it just means that it was once alive, or alive. So bioproducts are made from biological renewable sources. That just means plants. And bioproducts are not food or feed. And then we have 3 types of bioproducts. There's 3 main types: materials, chemicals, and energy. I know some people mentioned ethanol before, so ethanol will be under energy. So the different types of bioproducts are materials, chemicals, and energy. For materials, we will have plastics, so we can make plastic from plants. We can also make fibers from plants. We can make rubber. For chemicals, I can think of lab chemicals. We can think of chemicals for cleaning, hygiene products like shampoo or makeup. Medicine will also be considered a chemical, and we can make those from plants. And then for energy, we can think of biodiesel. So here's when people mention ethanol, we'll like fit it into biodiesel, bioheat, and biogas, methane that we can make from plants. So now we're gonna go over 3 different crops and the types of bioproducts we can get from these 3 different crops. So from corn, we can make textiles or cloth. We can also make biopolymers, and these are like plastic materials, like plastic-like materials. Like we can make cups. We can also make fabrics or carpet. From corn, we can also make xanthan gum. So xanthan gum is a thickener that we can add to products. So maybe if you looking at your salad dressing, maybe lotion or shampoo, like on the ingredients, you're probably gonna read xanthan gum or other type of gum in there, and just makes the product thicker. Also vitamins, we can get vitamins from corn or amino acid supplements, and we can also get citric or lactic acid. So citric and lactic acid also are many products that we consume. Maybe citric acid, maybe in your sodas or juice. These are like to make, to give the sour flavor to things and also to preserve. And lactic acid, that's for milk. So not for milk, but it can be in your yogurt or cheese, also gives like sour flavor and also preserves things. For soybeans, some of the bioproducts we can get for soybeans are inks and paints and also glues. We can also get biodiesel, just like from corn. We can also get candles. We can get cleaning supplies, shampoo, hand sanitizer. We can also make clothes from soybeans. So this company that makes these types of baby clothes, they actually make the clothes from the leftovers of the process of soy milk. So whenever, if you guys have ever heard of soy milk or had soy milk is made out of soybeans. And soy milk is it's liquid, it doesn't have any solids, but the soybean is solid. So after you make the soy milk, you are left with like the pulp, like when you like drink orange juice and there's like solid things in the orange juice, that will be the pulp. So at the end of the process of making soy milk, you're left with a lot of solid material that normally would just be thrown away or used for something else that's not making clothes. But this company is using the leftover material to actually make clothes, baby clothes in this case. The last one, Wayuli, which we mentioned before, Wayuli, which can be grown in the Sonoran Desert, we can get these bioproducts. We can get rubber. So rubber is very important because from rubber, we can make tires. We can make tires, or we can also make other types of material, other types of products like balloons, gloves. We can also make biodiesel, and we can also have organic resins, which those can be glue or to varnish furniture or for glazes. So now I want to tell you guys some of the history behind Wayuli. So Wayuli, it became very important some years ago because there was a big problem when there was during World War II in 1942. So we use a lot of rubber to make all the tires. So every single tire on a car, on an airplane, anything needs really strong tires. So to make really strong tires, we need natural rubber. Yes, humans, we can make rubber, but it's not as good. And so if the stronger the tire, the more natural rubber it needs. So in 1942, during World War II, the United States was cut off from the natural rubber supplies in Asia. So all the rubber from the world comes from one place, Asia, from one type of tree. If there's only one type of tree in one area in the whole world where we get the rubber. So if it was cut off, so the United States had no other way to get natural rubber. And we needed rubber for, especially during war, you need it for all the vehicles and airplanes. So Wayuli started being grown in the southwestern part of the United States in order to get the rubber. So there was a problem, and the solution was like to find a plant that we could grow in the United States and we could get the rubber from. So Wayuli can be grown in this area, southern part of the United States and northern part of Mexico in the Chihuahuan Desert. So this is the wayuli plant, and here are the little flowers that come from the wayuli. Oh, so now we have an activity for you guys. We would like for you guys to create the ideal plant that can grow in the Sonoran Desert, but can also solve a problem or need that you have or the world has. So the plant has to have the growing conditions from the Sonoran Desert. So it shouldn't need a lot of water, since there's not a lot of water here in the Sonoran Desert compared to other places. It should be able to like full sun. It should like pH between 7 and 8.5, and it should like the climate here, which is dry. So you should like name your plant. You should have the problem that you want to solve and the solution. So maybe the bioproduct that this plant can give you to solve the problem. So an example that we just talked about was wayuli. So here's the name, wayuli. And the growing conditions we already know requires full sun, requires very little water. The ideal temperature is between 90 to 100, and the type of habitat is desert. But the problem was like airplanes and cars need strong tires, and the solution was that wayuli makes rubber to make strong tires. So we would like to give you guys some few minutes to think about the name, the problem, and the solution. And after you guys have thought about this, can you guys share it in the chat? Oh, and this plant, you can just make it up, and it can be anything that you want. You can name it however you want. Okay, I'm seeing that 2 people have shared their plans. I'm gonna give like 1 more minute or so in case someone else wants to share, and then I will read some of the responses. Okay, so I'm going to share some of the responses. So we have, someone will have a plant called Shasta plant, and it would heal an injury and smooth it and could deal with the heat, and it loves the sun, the Shasta plant. Another one is the happy plant that will bring happiness to the world. So all these are really nice plants. And we also have the picnic tree, which will grow in the desert, and it will have very wide branches for shade. And we could sit out there in the desert and have a picnic under the tree. And we also have the deer bush fruit tree, which it will grow every type of fruit. And then we also have the healer plant, which it will heal all injuries and it will have all these medical uses. And we also have the prickly cory plant, which it has thorns that are very sharp to keep animals from injuring it. And it has very long roots that are like tubes to find water. Okay, so these were all really good responses, and all the problems that your plant would solve are a really big problem. So, yeah. So now we have, after this activity, we have another activity, which we will be asking you guys this question about what we just went over. So I'm gonna spin on this wheel, and once I stop it, it's gonna land on a question, and you guys can use the chat to answer that question. Okay, so this is a true or false question. Textile industry uses corn for bioproducts such as shoes and clothes. So we have one response, two responses. Yes, so we all got that one. That one's true. The textile industry does use corn for shoes and clothes. Next question. I landed on the same one. Okay, another true or false question. Bioproducts include both food and non-food products. Okay, so I see the responses are all correct, false. So bioproducts only include non-food products. If it's food, it's not a bioproduct. Food or feed? It keeps landing on the same question. Okay, so what are the three main types of bioproducts? So remember there were three. Can someone name the three types of bioproducts? Or one. If you remember only one, you can just write one, and maybe we can all get the three with everybody helping each other. Okay, so I see right now everyone's typing like examples of the different types, but I can go over the different types. Some examples are medicine, biodiesel, and clothes, but we have three types. We have materials, so textiles and plastics will fit under materials. The second one, we have chemicals, so like shampoo, hand sanitizer, medicine will fit under chemicals. And the last one is energy. So for energy, we will have biodiesel there, we'll have biogas there, bioheat. So the three main types are materials, chemicals, and energy. And Alice, should we do another question or should we?
I think we are doing fine with time if you like, yeah.
Okay, so one more question. It keeps landing on the pink question. Okay, so the last question is summarize the plant growing conditions here in the Sonoran Desert. So if someone wants to talk about water, sun, or the soil, or the climate in the chat box, and we can combine all the answers and talk about them. So yes, growing conditions in the Sonoran Desert. So we're talking about water. We have we don't have as much water compared to other places. We have a lot of sun, and the pH soil. Yes, someone mentioned the pH soil. The pH soil, it's around 7 to 8. So it's basic. And what about the climate? What type of climate do we have? Is it humid? Is it cold? Yes, someone said the climate is hot and dry. And somebody else mentioned that desert plants have to love the sun and also have to be able to go without water for a while, which is true. Okay, so all you guys, all the answers were correct for the plant, the growing conditions in the desert. So now we're gonna continue with the presentation. We're gonna go to the next one.
All right, thank you, Arisbeth, for all the great information. It looks like our participants mastered the content very well. Now, in this slide, I will be talking about what you as school-age individuals or students, what skills you can develop as you are going through your school. So I guess some of you would like to major in science in the future. And science is a huge field with different specializations and skills needed, if you remember my earlier slide. But you can currently start developing some of the skills that I mentioned earlier, even if you are a scientist yet. I have a daughter in the elementary school, and she says she wants to be a scientist in the future. And when I tell her what she can do now, she changes her words. She says she wants to be a kid scientist now, so she doesn't want to wait. But in fact, you are developing a lot of literacy skills right now in the school, and the whole idea of going to school and taking science classes is to gain some of the scientific literacies and understand science. So what can you do as a school-aged student right now? So in your classrooms, as you take science classes, you are developing you are developing scientific literacy skills, and some of which are listed here. For example, you are maybe engaged in some kind of experiment, and you are using some lab tools. Even if you are not, in the future you might, maybe in the high school, but you want to understand how those lab tools work. And you are also probably being asked to write a hypothesis or design an experiment. So making sense of how a scientist works is a great thing to learn right now and understand right now. And sometimes you might be given a small bit of data to look at and interpret in your classes. So try to just do your best. And if you're asked to even visualize it on a graph, that's great. So those are all great skills. And I always think that reading science keeps your interests high. So if you are interested in different scientific topics, keep reading magazines, websites. So that's going to add a lot to your current science knowledge. Also, I think your teachers might be asking you to write maybe some reports on experiments if you are doing experiments at this point, if not in the future. So being able to write good reports or being able to summarize and explain what you did is an important scientific literacy skill. And also, as you write, remember you are using academic vocabulary and scientific terminology in your writing. So scientists communicate primarily via writing, but they also communicate by sharing their data publicly, in different platforms. So if you have an opportunity to attend a science fair, maybe attend it, do your best, and try to go to different levels of it and share your science projects and ideas with the public verbally as well. So as school-age individuals, you can currently develop your scientific literacy skills. And remember, people's literacy levels are very different. So if you keep reading and try these and do your best, you can be better in some of these skills. And in the future, if you decide to go to college and major in science, maybe in any of the science fields, you will be able to use these abilities. And here are some career tracks that I wanted to share with you if you decide to major in plant science. When I was teaching, I was also providing guidance on different careers. So if you decide to major in plant science, for example, at the University of Arizona or somewhere else, you can go in different tracks. Like you can focus on one of the specializations, such as like plant genetics, plant breeding. If you're interested in seed production, you can specialize in that, or plant pathology. So, so even if you pick a major, there are a variety of things that you could do with that. You can, for example, use technology that's involved in all of those industry processes, and you can find a solution to a problem. So there's also heavy technology involved in this. And here is a great resource that I would like to share, and I used with my students when I was a teacher before becoming a PhD student right now, and that is College Board's Road Trip Nation resource. So in this resource, you are able to narrow down your interests, and if you would like to read more about maybe environment and nature, you can just narrow down your interests. You are using the filters, and you can get such great information as like job trends in the US right now. For example, you can see that environmental scientists, soil and plant scientists, biologists, there is an upward trend in the careers related to plant science, agriculture, and you see that there are a variety of paths here that you could pick. So I would highly suggest that you take a look at this. And it's a free resource if you have an account on College Board's website. And another resource I would like to share with you is from the project that I and Beth are working, which is a YouTube channel, SBAR Education Videos. Currently, we have recently started this. So we currently have several interviews with some scientists in the agriculture field or related fields. You know, there are a wide variety of interviews here. You can listen to these real scientists who live in Arizona or neighboring states, and you can see what they are doing in agriculture field and what kind of skills they are using right now. So I hope this one and also the College Board's Road Trip Nation could be some good resources for you all. So we now would like to open it to the questions. Thank you very much for being with us during this time. We forgot to ask you what school level you're at. So as you're asking your questions, if you can also tell us if you're at an elementary, middle, or high school, then that would give us about our audience today. Thank you very much for listening today.
I'll help a little here with the question and answers. I did want to take time just to thank very much our panelists for bringing their expertise with us and putting together such a great presentation. I did see that one of our attendees did a hand raise tool. If you could just type your question into the question and answer session or the question and answer section, then we can get to it. If I'm looking at this, we have one open question at the moment. I was wondering if you become a scientist, if you get enough knowledge and content in college to do many things like a plant scientist and engineer. Can you learn that many things? Are they sort of based on the same things? Sounds to me like the question is around, maybe what to expect studying science in college and its preparation for you to become successful in as a scientist in a career.
Let me briefly answer that, and Arizbeth, if you'd like to add anything, you are welcome to do as well. So when you look at any course of study at the university, like at college, you'll be able to take a variety of courses. So the goal of majoring in one science major is not just to give you very specific kind of knowledge, but also try a broad range of skills and types of knowledge. So by taking different courses in the major you pick, you're able to learn about a variety of things, and then you can decide what specifically you want to do. So you always take probably a couple years at least in college before you finally decide who you want to be and what you want to do. So you'll have plenty of time at the time.
So yeah, when you go to college, you can decide if you want a career in engineering or a career in science that's not engineering. But if you pick to be an engineer, because I'm an engineer, so now I'm in research, we has to do like solving problems and just doing research, which is like a scientist and also engineering at the same time. So you can also like change later or focus on the things you like. Maybe you think you like something, and once you try it, you're not gonna like it. So just go in a direction that you like at the time, and maybe you're gonna get more focused in with time once you're in college.
Great answers. Thank you for that. And I know that reading some of the chats that our attendees here are fairly young, and I want to let you know that there is nothing wrong with having a dream right now and see where it takes you, and then going off in a different directions as you grow and as you learn and experience new things. I think Arizbeth and Ali would both say that careers are not necessarily linear anymore in the sense that you leave high school and you want to be, say, a teacher, and then you go to school to become a teacher, and then you become a teacher, and then you retire someday. That was my initial plan, and I taught for 5 years and went in different directions. So, be thinking about the things that you enjoy. Even as a kid, what sort of things do you enjoy? Do you enjoy being outside in nature? Do you enjoy, science activities in your school? Do you like to be inside and play with things like microscopes? All of what you're experiencing now as a young person can be very influential in helping realize what the core interests that you have are and get you started off in a college experience. So keep your minds open and stay active and engaged in scientific activities, and you'll find the right direction. And if there aren't any more questions, I don't see any at the moment. I just, again, want to thank our panelists for sharing their time with us today. It is great to bring our partners into these sessions. Oftentimes, our 4-H youth are engaged mostly with their volunteer leaders and their county agents who are experts in their own right, but we certainly use these great opportunities to connect our 4-Hers with our partners at the university. So thank you for joining us, and thanks for being a great partner for 4-H. And we look forward to more engagement as we move forward. And the last thing the last thing I'll summarize or sum up today, just to remember, you can even think about how this presentation was connected to the one yesterday. But I love the engagement. I love the activities and the problem solving, and even those simple activities and games, if you will, are and especially the creative one of dreaming up a plant. I think that's great. Give us a really cool opportunity to put these skills to use. So Arisbeth and Ali, thank you so much. And hopefully we can connect you in some new and different ways to our 4-Hers again.
Thank you very much, Nick, for the opportunity. It was great to be here. I just want to let everyone know that I shared the links in the chat box as well. So if they would like to try them, not later, but sooner, here they are.
Excellent. And we will be making this this recorded presentation available on the virtual programs website or webpage where you found the registration link. So over the course of the next couple of days, this video of the presentation will become available, and we'll also add those resource links as well. So we'll make those certainly available. So those of you who were here and had a great experience, you can share that with your friends in 4-H and elsewhere. And since there aren't any more questions, I will turn everybody loose to have a wonderful, wonderful Tuesday. And I wish you all well. Tomorrow's presentation will be from 10 to 11 on the topic of equine science with Dr. Betsy Green. We will then have livestock / dairy presentation with Dr. Duarte Diaz on Thursday, and then Dr. Jerry Lopez with food safety from the fields to the table on Friday from 10 to 11. So we welcome you to come back each day, or if you wish to select one or another, that's up to you, but good to see you as always. Take care, Arizona 4-H, and we'll see you tomorrow.
Thank you.